Hello guys, welcome back to my channel Life with Chemistry. So today I would like to discuss about atomic structure, and this is a super cool formula sheet guys, because I've covered all the formulas from atomic structure. So this single formula sheet is completely enough for any entrance exam, whether it is CSIR, IIT JAM, SET, GATE. For any entrance exam you could just go through this formula sheet and attempt. And I've also discussed a few previous entrance exam bits, so please do watch the video till the end. And you could just use this sheet as a reference also, like last minute reference. And please do pause the video and write it down, or you could just note it down. Coming to the formula sheet, as you could see here, this table is very important guys. You should just memorize all the numericals from this table. They could just insert any of these numericals in any problem, so it is very important to note this table and memorize the numericals. And there is also a small table below it, and relative mass compared to electron. They could ask directly from this table also. And if you could see this left side box, that is M A Z, where M is any element. And some might forget way to write mass number and way to write atomic number. So mass number, as it is heavy, it is written above, and atomic number is written below. I'll just roll it down. So as you could see, atomic number is denoted by Z. Atomic number is nothing but number of protons or number of electrons in a nucleus of an atom. And mass number is denoted by A. It is nothing but number of protons and number of neutrons. I've just written plus over there. And there is a Planck's equation below, where E is equal to h nu, where E is the energy, h is the Planck's constant, and u is the frequency. Frequency is nothing but speed of light, that is c, by lambda, where lambda is wavelength. And it is very important to note Planck's constant also. They might just confuse you with their units, so it is very important to note the units also. And there is also this de Broglie equation below, and where de Broglie equation is nothing but lambda is equal to h by mc, or h by mv, or h by p, where p is momentum is given by p is equal to m into v. So, and there is a simple simplification. They could ask directly from this simplification also. So please pause the video and note down this simplification. Coming to the right side of this box, that is Heisenberg uncertainty principle. As you know that Heisenberg uncertainty principle is nothing but it's not possible to determine the position and momentum of an electron simultaneously. That is delta x into delta p is greater than or equal to h by 4 pi. And delta p is nothing but momentum, where momentum is equal to m into delta v. So there is this important symbol guys, that is h dash, sorry, h dash. So I don't know what they call, but I just call it h dash. So h dash sorry, h dash is equal to h by 2 pi. So they might confuse you by giving this h dash also, so please be cautious. And Heisenberg uncertainty principle can also be given to energy and time, as you could see this formula over here. And there is this hydrogen spectrum. I'll just roll it down. So this is the hydrogen spectrum. I think most of them might know this hydrogen spectrum also. So this table is also important guys. So this spectral series, this region of series, n1 and n2 values are important. Lyman, Baumer, Prashen, Brackett, Fund, Humphrey, and this n1 and n2 values are important. And coming to the hydrogen spectrum equation, so this is the equation. Before knowing the equation, you should know that wave number, that is nu bar, is equal to 1 by lambda. So you could just write this equation like this: nu bar is equal to 1 by lambda is equal to r into z square into 1 by n1 square minus 1 by n2 square, where r is this Rydberg's constant. There's this simple trick to remember this Rydberg's constant r. I'll just tell you that simple trick. So as you can see here, so in this number, see the last three digits, that is 6 7 8. So 6 7 8, after 8 9, and then 10. So 6 7 8 9 10, that's it. That is a Rydberg's constant. Last three digits is 6 7 8, and then 9, and then 10, that's it. So, and among this series, this Baumer series is very important one. And as you could see here, for Baumer series, N1 is 2 and N2 will be 3, 4, 5 and so on. So if they ask for H alpha series of Baumer, so for H alpha, N1 is 2 and N2 is 3, and you should substitute this N1 and N2 values and solve the problem. If they ask for H beta, it is N1 is equal to 2 and N2 is equal to 4, and so on. For H gamma, it is N1 equal to 2 and N2 is equal to 4. Counting the number of lines in a transition. If a transition takes place from N2 to N1, the number of lines is equal to summation of N2 minus N1, or this formula. You could just follow any of these formulas. I have also given this example. If an electron returns from 7th shell to 2nd shell, then the number of lines is. So I've just used this formula first. So that is 7 minus 2 into 7 minus 2 plus 1 by 2. I've got this 15 lines, and I've also used this second formula. So 7 minus 2 is summation 5. Summation is nothing but adding up all the numbers till the end. That is 1. So I've also got the same number. And coming to the longest wavelength. Longest wavelength is from second shell to the first shell, and shortest wavelength is from infinity to first shell, as energy is equal to 1 by lambda. So they both are inversely proportional, and this angular momentum of an electron, mvr, is equal to nh by 2 pi. And this there is important formula of radius of nth orbit, that is Rn is equal to n square h square by 4 pi square mz e square, where n is the shell number or principal quantum number, m is the mass, z is the atomic number, and e is the charge. After substituting all these formulas, we get this very important formula, that is Rn is equal to 0.529 n square by z Armstrong units. So they might ask the relation between a radius of an orbit and the principal quantum number or atomic number. So this formula is also important. So I've also given some example. As you could see here, for helium, the electronic configuration is 1s2, and where n is 1 and z is atomic number where it is 2. After substituting, I've got this answer. So you could just note down this example by pausing the video. And there is this electron velocity of an electron. Velocity of an electron is nothing but 2 into 1.8 into 10 power 8, so into z by n. I think in CSIR or some exam they've asked this direct that they have asked this direct relation of velocity and principal quantum number. So these relations are important, guys, whether it is directly proportional or inversely proportional. So you should just remember this one. So please note it down. And coming to the right side of this box, I've also given this example. As you could see here, velocity of an electron in the first shell, that is v1 of the first shell of helium atom, where n is equal to 1 and z is equal to 2. So that's it. And coming to the energy of an electron, is very important. Energy of an electron, that is kinetic energy. For kinetic energy, this is the formula. For kinetic energy or ionization energy, this is the formula, guys. So this for kinetic energy or ionization energy, this is the formula. And for potential energy, this is the formula. This is the formula for potential energy. So it is important to note this potential energy also. And coming to the total energy, it is minus 13.6 z square by n square. So minus this potential energy, and total energy has minus, but ionization energy or kinetic energy will not have this minus symbol. So and sometimes they might convert the, or they might change the units of energy. And so these are the another units of energy. So energy can also be written in form of ergs, as you could see here, and also they could be written in joules. I'll just roll it down, and they could just write it in kilocalories also, kilocalories, and then kilojoules per mole, kilocalories per mole. And there is this important formula. As I don't have space, I had to fit this ionization energy in this small box. So I hope you could see this. So ionization energy of any atom is equal to ionization energy of hydrogen into atomic number square by principal quantum number square. So that is the formula of this ionization energy. So this is the Schrodinger wave equation. This is a excuse me. And this is the Schrodinger wave equation, guys, so it's very important to know this equation also. Sometimes they might ask directly. So and then there is this important numbers, that is number of shells, subshells in a given shell is equal to n. Okay, and then for 1s n value is 1. So for 2s n value is equal to 2. So the number of subshells in 1s is 1 and in 2s is 2. So that is how you could just solve it. And there are these simple formulas. There are this you could just pause the video and note this down. All these are very important, especially this this one, the number of spherical or radial nodes. They might ask directly, guys, so it's very important to note this spherical or radial nodes. All these are very important only. So angular nodes is equal to L. Okay, just L, that is azimuthal quantum number. So this is the complete formula sheet, guys. So as you could see this single sheet, you just note down all these formulas, and that's it, guys. You could attempt any question from any entrance exam. So that's it. For this is the formula sheet. And I'll be discussing this previous entrance exam questions now. These are the previous entrance exam problems in atomic structure, that is from CSIR, GATE, and also IIT JAM, and also from SET. I've discussed few problems. So as you could see here, this is a problem from CSIR 2013 December. This question is asked for 2 marks. So the orbital with 2 radial and 2 angular nodes is. So you need to substitute all the options in the formulas as I've given these formulas before, radial nodes and angular nodes. So number of radial nodes is equal to n minus L minus 1. For 5D, n equal to 5 and L equal to 2, that is azimuthal quantum number. For S equal to 0, P equal to 1, and then D equal to 2. So as after substituting, I got this 2 radial nodes, and angular nodes is L, that is azimuthal quantum number. For 5D it is 2, so the answer is 5D. I just substituted this options, that's it. And then coming to the below question, that is CSIR's June 2014 question. This question is also asked for 2 marks. So if the ionization energy of hydrogen atom is X, the ionization energy of lithium plus 2 is. So this is the formula, as I have given this formula before. So you could just note down this formula and solve it. It's as simple as that, guys. So for lithium ion, then lithium plus 2 ion, the electronic configuration is 1s1, where n equal to 1 and Z is atomic number, which is equal to 3. You could just apply the formula directly here and you get the answer, guys. That's it. So answer is 9x. And coming to the below formula, it's very easy, guys. I don't know how did they give this formula directly. So this is a 4-mark question that in June 2014 CSIR question, 4 marks question. So the ground state energy of hydrogen atom is 13.59. That's almost approximately equal to minus 13.6 electron volts. So the expectation values of kinetic energy, they ask directly this kinetic energy and potential energy values. So that's it. So after giving this energy values, they have asked this kinetic energy and potential energy values. As we have discussed before, for kinetic energy, the formula is this, and for potential energy, the formula is this. So they have just removed this n square and z square values, n square and z square. So you could just attempt it directly if you know these formulas. So the answer is A. Coming to the right side of this box, that is CSIR June 2016 question. So this question is asked for 4 marks, guys. So the ionization energy of hydrogen atom in ground state is approximately 13.6. They have given this ionization energy, and they ask for the potential energy of helium plus ion in ground state approximately. So these are the options that have been given here. So you should know this potential energy formula, guys. If you know this potential energy, you can just substitute this n1 and n and z values of helium plus ions directly in potential energy and solve it. So for potential energy, this is the formula as we have discussed. So for helium plus 1, electronic configuration is 1s1, n equal to 1, and z equal to 2. So after substituting, I got this value. So the answer is D. That's it. And then coming to this below question, CSR December 2016, 4-mark question. So they have asked this orbital degeneracy. The orbital degeneracy of the level of a one electron atomic system with Z equal to 5, Z equal to 5, and energy is this minus 13.6 electron volts. So as we know this formula of energy, E equal to minus 13.6 into Z square by N square, given that minus energy is minus 13.6. So that means Z equal to N. So as Z equal to N, so and you should, as I've given before, so the degeneracy of one electron system is N square, and after solving this we get 25, so the answer is 25. And this is a gate question, guys, direct gate question. See, I've told you this H dash, so I guess you remember this. So let's get into this question. So this is a gate 2012 question. If delta y and delta px are the uncertainties in y coordinate and the y component of the momentum of a particle respectively, then according to this uncertainty principle, delta y into delta py is. So they directly ask this uncertainty principle formula by confusing you. So, and they have also given this H dash, so you should be careful while choosing the answer. If you know this uncertainty principle formula, you could just attempt this directly. So I've just given here, you could just go through. These are the previous set exam questions, guys. So this is from TS set 2014. The number of radial nodes for 3s orbital. So radial nodes, so direct question, guys. If you know this radial nodes formula, you could just attempt it directly. It is 2. So the answer is, after substituting all these n value and l value, you get 2. So the answer is C. And coming to the below question, TS set 2013 question. The Baumer series in the spectrum of atomic hydrogen arise from the transition. So they have asked N1 and N2 of Baumer series. It's as simple as that, guys. So for Baumer series, N1 is 2. So the answer is B. That's it. And coming to the below question, that is TS set 2012 question. So they have asked this Planck's constant, value of Planck's constant. So you should know this units, guys. They have confused you with this units. So they have given you this A and B. So here the difference is they have given both the units in joules and seconds. So you should know these formulas in joules as well as in ergs. So please do watch these units, okay? And then there is this set question. This is very easy and important question, guys. These are similar questions that you can see in any entrance exam. So I've just written this simplification in the right side part of this paper. You could just pause the video and go through the video, go through this simplification. So you'll get this answer. And this is this IIT JAM question 2016. The effective nuclear charge of helium atom is 1.7. So the first ionization energy of helium atom in electron volts is. So effective nuclear charge is nothing but Z square, or that is effective. You could just write this atomic number as Z effective also. So in order to confuse you, they might give like this. So you should remember this one also, that is ionization energy formula is equal to 13.6 into Z effective whole square by N square. And this is the formula, this is the simplification. And that's it, guys. So all these questions are directly from this formula sheet only. You could just attempt any question from this formula sheet. So, and best of luck, guys. Keep going, keep practicing, and keep encouraging. Thank you for watching this video.